Density Determinations Lab, featuring the color-coordinated dynamic teaching duo Mr. Gottlieb and Mrs. Valatek. Part 1. Liquids. Obtain a clean, dry, graduated cylinder. Place it on the balance and press the tare button in order to zero out its mass. Add a sample of a liquid to the graduated cylinder. Record the mass of the liquid in your data table. Carefully measure the volume of the liquid by getting down to eye level and reading from the bottom of the meniscus. Let's make some calculations. In order to determine the density of the liquid, we must take the mass of the liquid and divide by its volume. Units are grams per milliliter. Part 2. Regular solid. Determine the mass of the regular solid. Record this mass in your data table. Measure the dimensions of your solid using a centimeter ruler. Be careful to observe significant digits here. To calculate the density, first calculate the volume of the block from its dimensions. Divide the measured mass by the calculated volume to determine its density. Units are grams per centimeter cubed. Part 3. Irregular solid. Determine the mass of your dry rock and record it in your data table. Add a known volume of liquid to your graduated cylinder and record this volume. Carefully add the rock to the cylinder and record the new volume. Remember, get down at eye level and measure at the bottom of the meniscus. Determine the volume of the rock by taking the difference in volumes read off the graduated cylinder. Final minus initial. Calculate the density of the rock by dividing its measured mass by its determined volume. Units are grams per milliliter. Part 4. Graphical method. Take a small graduated cylinder and tare its mass. Add water. Record the mass and volume. Continue to do this until you have obtained at least 3 sets of data points. Note that the mass and the volume continue to increase each time.
That's enough.
Part 5. Aluminum pellets. Obtain a graduated cylinder with a known volume and tare its mass. Be sure that there is a known volume of water in it as well. Add 2 aluminum pellets and record the mass and volume. Continue to add aluminum pellets 2 at a time, recording mass and volume as you go. You will calculate density from each set of mass volume data obtained. Then calculate an average of those values.